Hi, in this playlist we're going to be looking at the Edexcel November 2018 paper 3 for the higher tier. I'm going to aim for the whole paper to be broken down into 3 or 4 different videos of about 20-25 minutes or so in duration. Please do stop the video, have a go at each of the questions, compare your solutions. Should give you roughly about an hour's worth of fairly focused revision. If you're not sure about anything, always add a comment below, and I look forward to seeing you inside the video. Hi, this is the second video in the playlist where we're looking at the November 2018 Edexcel Higher Paper 3. Please do stop the video, have a go at each of the questions and compare your solutions. So in the previous video, we completed through to question number 6. This is going to start from question number 7 onwards. I'm going to aim for about 20 to 30 minutes or so, and that should give you around about an hour's worth of fairly focused revision. Okay, so this one is one that doesn't come up too often. It's actually a frequency polygon. It's a little unusual to find these in GCSEs these days, but they tend to favour histograms and things like that. But frequency polygon is okay. Basically, all you're doing is you're plotting the midpoints. So 5, 15, 25 and 35. And in this particular case, we're going to plot the midpoint 5 against the frequency 14. So that's going to be something like 5 and 14 is there. And then we've got 15 and 18. So there's 15 and 18 is about... where's 18? It's about there, I think. And then we've got 25 and 26. Well, that's going to be all the way up there. And then we've got 35 and 12, and that's going to be down there. So this is a very, very typical shape for a frequency polygon. It's always like some sort of mountain. Okay, and again, apologies for my freehand, but it'll give you some idea of what it is you're looking for on that for a couple of marks. Okay, let's move on then to question number 8, which I must admit, it just takes a little bit of thinking through, but basically all they're doing with this is they're saying, you know, if you've got an area of 27, 45 and 15, that area is made up by the lengths of each of the sides. Now, it's a bit kind of one of those where I think you've either got to see it or you don't see it. It's one of those sorts of questions. The only way of making this box kind of work for you is if I said, well, that's 9 and that must be then 5 and that must be 3. Now, the reason that's the case is because 9 times 5 is 45. 9 times 3 is 27 and 5 times 3 is 15. So actually what we've got now is the dimensions of the box, which is what we actually want. So it's a little bit of a tricky one, I think, sometimes. And you've got to kind of have that clarity to be able to sort of see these sorts of questions. Okay, so from there on in, it's not too bad to work out because it says it's made from metal, it's melted into cubes. Each of the cubes has a length of that. So basically, we need to find out the total volume of the large cube. By that, I mean this one that we're just looking at. So volume of large cube. Okay, now I posted a video recently on volumes, and volumes are always area times depth. Okay, I know people will multiply all of these numbers together, but really what we should be doing is saying that's the area, and then we're going to multiply it by 3. So that's going to give us a total of area of 135 centimeters cubed. Okay, so just be very careful. I would rather see area multiplied by depth every single time with these. Okay, so that's going to be the volume of this large cube. And then what we've got is we've got a small cube, which is this one with lengths of 2.5 centimeters. So it's actually a square cube, if you like. So we've got total volume of small cube. Okay, now what that's going to look like is just a square kind of sugar cube type thing. So that's 2.5, 2.5, and a height of 2.5. Okay, so the volume again is going to be the area times the depth. Okay, now this is going to be 2.5 times 2.5, and then the depth is 2.5. Okay, if you put that into a calculator, you're going to get 15.625 centimeters cubed, and that's going to be the volume of the small cube. Okay, so therefore the total number of cubes that you can make is going to be this divided by this. Okay, so therefore let's have a look. Total cubes is going to be equal to 135 divided by 15.625, and that's going to give you 8.64. Okay, well, it says the greatest number of cubes that can be made. Well, you can't make, or you can't, no use really of 0.64 of a cube, so therefore the greatest number of cubes is equal to 8. Okay, and that's the answer to that particular question. Okay, hopefully that was okay for you. Please do add a comment below if you're not sure about anything, and I'll always come back to you. Okay, let's move on then to question number 9. So question number 9, please stop, have a go at. I did actually post a playlist recently on expanding triple brackets. So this is very traditional, very typical kind of GCSE type question. The way I would do it is I would ignore the x minus 2 first, okay? And what I'm going to do is I'm going to multiply out these second brackets. Now again, I know there's various different ways of teaching this. I tend to use a kind of a crab claw type method. It sort of works for me. I know people partition, they do all sorts of things, but for me it works better if I just do 2x times x is going to be 2x squared, and then 2x times plus 1 is going to be plus 2x. So I've finished now with the 2x. I'm now going to deal with the plus 3. So plus 3 times x is plus 3x, and plus 3 times 1 is going to be plus 3. Okay, so I'm also again now going to just tidy that up a little bit, and I'm going to take my time doing this. So x minus 2, so 2x squared, and I've got plus 2x plus 3x is going to be plus 5x plus 3. Okay, so then I'm going to do exactly the same process, but this time I'm going to deal with the x minus 2. However, my first thing I'm going to do is deal with the x. So x times 2x squared is going to be 2x cubed. Okay, x squared times x is x cubed. Okay, and then I've got x times plus 5x is plus 5x squared, and x times plus 3 is plus 3x. Okay, so now I've finished with my x, and I can just move on now to my minus 2. So minus 2 times 2x squared is minus 4x squared. Minus 2 times plus 5 is minus times a plus is a minus, and that's going to be minus 10x. And then finally, minus 2 times plus 3 is going to be minus 6. Okay, or negative 6 if you prefer. Okay, let's tie that up a little bit. Well, 2x cubed I can't do anything about. That's just going to stay as it is. I've got 5x squared minus 4x squared is 5 minus 4 is plus 1, so it's plus x squared. Plus 3x minus 10x is going to be minus 7x, and then minus 6 at the end. And that was the answer to that particular question. If you're not sure and you want some more practice on that, please do put something in the comments, and I will send you through a link for the other playlist. Okay, so then it says part B, it says, here's this, what is it, an equation, an expression, equation. Find the value of n. So basically what we're saying is that if I divide through by y2, I can actually divide this through, and I'm going to get y squared times y to the power of n equals y to the power of minus 3. Okay, so all I've done is I've just got rid of that y squared. Just makes my life a little bit easier, okay? So if I do that, then I can say, well, actually, if I want y to the n, I can divide through. So y to the minus 3 divided by y to the 2. Okay, so minus 3 divided by, or y to the power of minus 3 divided by y to the power of 2 is the same as actually subtracting the indices. So basically what we've got here is going to be minus 3 minus 2. So we're dividing, so therefore we're subtracting. Minus 3 minus 2 is going to be y to the minus 5. So y to the n is y to the minus 5. So therefore, in this particular question, n must equal minus 5. And that's the answer to that question. Okay, hopefully that's all right for you. Okay, part C is 3 marks, so it's going to take a little bit of time, but basically the tell on this one is where it says 3 significant figures. Now it says that because it's going to be a calculator type question. And the way to do this probably is going to be using the quadratic formula. So you need to remember quadratic formula again. It's not fantastically popular, but they do come up from time to time. And if you remember it, you've got x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so we've got 3 values, A, B, and C. So our first value of A is where A equals 5. It's that first coefficient. B equals minus 4. Don't forget, it includes the sign. And C equals minus 3. Okay, and then really it's just a case of putting these numbers into the formula and we're going to get our values of X. Okay, so let's have a look at doing that. And again, I would try to encourage you to use brackets, because you need to remember we've got b as the value of minus 4, but we've got minus b, so therefore it's minus minus is a plus. This bit is going to become 4. Okay, so just be really careful about those sorts of things. And we've got plus or minus the square root, and again we've got minus 4 squared. Okay, it's b is minus 4 and we're going to square it, which is going to be positive 16. Minus 4 times a is going to be 5 and c is going to be minus 3, and we're going to divide all of that by 2 times 5, which is 10. Okay, so let's now extract a little bit of calculation from that if we can. Well, as I mentioned before, you've got minus and minus as a positive, so that's going to be 4. And then we've got plus or minus the root. Okay, so this is going to be 16. And then we've got minus 4 times 5 is minus 20, but minus 20 times minus 3 is going to be plus 60. Okay, so do be careful about these types of questions. Okay, so what I would always try to advocate that you always work out this is called the discriminant. It's the bit that's under the square root. It actually tells us whether this particular quadratic formula does actually have a solution. It needs to be a positive number in order for it to tell us that. So do be very careful about these sorts of things. I certainly wouldn't advocate that you put everything into a calculator. It's much better to separate it out if you can. And you get to the point where you've got 2 values. So you've got where x equals 4 plus the root of 76 divided by 10. And you've also got x equals 4 minus the root of 76 divided by 10. Okay, and if you put those into a calculator, you're going to get 2 values. The first value is going to be 1.271779, and this one is going to be minus 0.471779, something like that. However, the question has asked us for 3 significant figures. So to 3 significant figures, you've got 1.27 and minus 0.47, and this in our case 2. Okay, so that would be the answer to that particular question. It's worthwhile having the quadratic formula. It used to be printed actually in the exam paper. I know some of them still do that, but I'm not sure all of them do anymore. Okay, so we're about 14 minutes into the video, so we're going to kind of keep going just for a little bit longer, and let's move on then to question number 10. So again, please stop the video. All right, have a go at this. Okay, so this one, you've got function of x equals 4 times sine of x degrees. Find the function of 23. All it means really is put 23 into that particular formula. So the function of 23 is where you've got 4 sine and 23. Okay, so all we're doing is substituting that x for 23. Okay, put that into your calculator and you're going to get 1.5629 245 to 3 significant figures. The third significant figure is 6, so it's going to be 1.56. Okay, let's have a look at the next one. Then it says g of x equals 2x minus 3. Find FG of 34. Well, you've got to kind of read these things backwards. And again, if you're not sure, I do have a playlist on the channel that can help you with a few examples of these sorts of questions. So what we do, let's look at what happens when we've got the G of 34. Well, the G of 34 is taking this 34 and plugging it into that equation. So it's going to be 2 lots of 34 minus 3. So that value is actually going to be 65. And then basically we say, okay, we take this 65 and we plug it now into the function value, which is this one at the very top here. So actually the function of 65 is going to equal 4 sine bracket 65 brackets. Okay, put that into a calculator, you're going to get 3.62523. So to 3 significant figures, well, the third significant figure is 2. It's going to change to a 3. So basically, I would end up with 3.63, and that would be the answer to that particular question. Okay, hopefully that's been all right for you. It is worthwhile practicing these sorts of questions. They do actually come up on GCSE sometimes. I see them fairly frequently, so it's worthwhile having a go at. They're called, what they call functions, inverse functions and functions. Okay, worthwhile. All right, let's have a look at the next one then. So h of x is that. Ivan needs to solve the following equation. He writes that. Okay, what's the mistake? Okay, well, the mistake is that he square rooted both sides. Now, the square root of 25 isn't just 5. The square root of 25 is plus or minus 5. Okay, so you've got to be very careful about these, because remember what we said before when we were doing the quadratic formula, that actually minus 3 times minus 3 is going to be 9. Positive 9, or minus 4 times minus 4 is going to be 16. So therefore it follows the root of 16 is going to be plus 4 and also minus 4, as in the same thing with this one, where the root of 25 is actually going to be plus or minus 5. Okay, now if you want to get that mark, therefore you can say that x will equal positive 5 minus 4, which equals 1, which is the answer he got. But actually, he's also got the other answer, or x equals minus 5 minus 4, which is equal to minus 9. Okay, so he does need both values, and you might add a little bit of a sentence in there just to really be absolutely sure you're going to get that mark, but it is a bit of a throwaway mark. Okay, let's have a look then at question number 11, where we're being asked to sketch a graph. A bit of a nightmare when you're running a video, but I'll do my best on this. So basically what we're saying is that we've got to work out the tan, or show the graph of tan. There isn't really any easy way of remembering this. It is one of those questions where you kind of got to remember sort of what it looks like really, and this is going to go through 270 like this. Just use a ruler okay, or a pencil or something to get those straight lines. But basically, a tan graph is what they call an asymptote, or an asymptotic type graph, okay, where it doesn't actually get to be that value. So it goes something like this, and then you've got something like that, okay, and then you finally got something not very good, something like that, okay, and that's actually the tan graph. Just remember, it is probably the easiest way of dealing with these sorts of ones. Remember the sine, cosine, and also tan graph is also, you know, does come up occasionally. Okay, let's move on then to question number 12. I'm very conscious of the time on the video is now about 20 minutes, but we've got a reasonably large paper to go through, so I'm going to try and push this just a little bit further, if that's okay. So here's a pyramid, and the important thing with it is it's a square base, okay? So if we know that AB is 5, as it says, then actually all of the edges are 5, okay? So that might help us a little bit, because we're being asked to calculate the size of the angle TAC. So in other words, kind of TA and along here to C. And what we're told is that you've got this vertex, which is this kind of straight line here at 90 degrees, and that's actually 12 meters. But in order for us to work out the angle which we're going to use SohCahToa for, which is this angle here, we need to have this line length calculation. So this is what's important to us. Now what you'll see is that actually, if we've got a square based pyramid, is that we've got at the bottom here basically a right angle triangle where we've got two sides at 5. And this is right angle, and this is going to be A, and this is going to be C, and if you like, this is D, okay? So therefore, we can use Pythagoras to work out that value AC. Now, bearing in mind, that's the whole length. So what we'll need to do when we get this value is divide it by 2 to get this length along here. But let's get the value first. What I'm going to say, and again, I'm conscious people will use slightly different notation to me. I would tend to use B squared plus C squared. Basically, A squared is this one along here. So it's 5 squared plus 5 squared. So that's going to be 25 plus 25, which is going to be 50. So therefore, A, which is the length AC, is going to equal the root of 50. Okay, so if I want to know then the half of it, it's going to be root 50 divided by 2. So if I just write this in here, root 50 over 2. I don't know whether you can see that too well on the screen, but it's root 50 divided by 2. Okay, so what we've got now is a triangle. And what we're told is that we've got, this is right angle, this is the point T, and this is the point M, which is this midpoint here. And we're told, or we've worked out now, that this must be root 50 over 2, and this height here is 12 meters. So that will allow us now to work out this TA, and C is over here somewhere, but this angle that we're looking for, which is this angle at the bottom here. Okay, so if I kind of just label this up as I would a normal right angle triangle, what I've actually got is going to be, this is the opposite, this is the hypotenuse, which is the longest side, and the last one left is the adjacent. Okay, so I can now write SohCahToa, and what I'm going to do is I'm going to figure out which one of these ratios I need to actually use. Well, the one I'm going to choose is going to be the tan ratio, because I know the opposite. I've got that there, and I'm interested in the I've got the adjacent rather, and I need to work out the tan. So I've got those two, and I'm going to work out the tan of the angle, or I'm actually going to use that to work out the angle itself. Because I can say that tan of X, which is this one here, is equal to the opposite divided by the adjacent. Okay, well, the opposite is 12, and the adjacent is going to be root 50 over 2. Now, you notice that I'm not really calculating that. I could, I can't remember what it is. It's some very long, boring number. But at the end of the day, just root 50 over 2 kind of works all right for me, because I need to use this information to work out the actual angle. And what this is going to do is give me the tan of the angle, which is of less interest. I need to use that to get the actual angle. And the way I do that is on my calculator, just above the tan key, I've got the inverse function, which is this -1. It's usually there by pressing the shift and then tan, and that will give you access to that key. And if you use a fraction, you can just type this straight in to the calculator, and you're going to get 73.5835. okay, so to 1 decimal place, this would be a angle of 73.6 degrees. Okay, and that's to 1 dp. All right, and that's the answer to that particular question. Okay, so hopefully that's been helpful for you. That's through to question number 12. I think we'll stop at this particular point, and in the next video we'll start from question number 13 onwards. Please do add a comment below if you're not sure about anything. There are quite a few playlists on the channel that I can direct you to, and I'll look forward to seeing you inside the next video, where we'll start from question number 13 onwards.